So students, before understanding sodium and potassium pump, that how materials are transported through sodium and potassium pump, we have to know one thing. This is plasma membrane. Now the fluid which lies inside the cell, that we call it as ICF, intracellular fluid, whereas the fluid which is outside the cell, that is called ECF. You know that in case of multicellular organism, they are having tissue level of body organization, and cells have combined to form tissue, tissues have combined to form organs. So each and every cell or each and every tissue is surrounded by a fluid, and that fluid is called extracellular fluid. And you know that both type of fluids, they are made up of organic and inorganic chemical compounds. And all these organic and inorganic chemical compounds, they are present in ionic form. They are not found in molecular form, but they are in ionic form. Now, the overall and ions, you know that charged molecules or charged elements, whether it is metal, non-metal, they have charge. So overall charge present in ICF, that is, ICF always remain negatively charged. The overall charge present in ICF, that is negative charge, whereas overall charge present in ECF, extracellular fluid, is positive charge. Means ECF always remains positively charged and ICF always remains negatively charged. Now see here, the ECF, it has high content of sodium ions, whereas the ICF, it has high content of potassium ions. Now what happens here? You know that in living organisms, metabolic processes, metabolism is continuously going on, and due to metabolic processes, what happens in ECF, the positive charge start increasing, and due to increase means it should be always in equal number. The overall positive charge present in ECF should always equal to the overall negative charge present in ICF. Now due to metabolic processes, what will happen? The positivity of ECF increases, and due to increase, here I have shown you the sodium channels. These are also porine channels which are present in plasma membrane. In previous lecture I explained you about integral proteins, that they are porine channels are there, and these porine channels are in form of sodium and potassium pumps. So as soon as the positivity of ECF increases, what happens? The sodium pumps, they open. This is the sodium pump. It remains closed when the positive and negative charge are in equilibrium state. But when positivity of ECF increases, now there is this balance of charge between ECF and ICF. Then what happens? This sodium pump, it opens. It opens, and the materials from ECF, they come into the cell. In the same way, the overall charge in ICF should be negative charge. Now due to movement of sodium ions, what will happen? The positivity of ICF will increase. Now ICF should always be negatively charged, but due to entry of sodium ion, it will slowly it will become positively charged. So in order to bring the membrane in polarized condition, in equilibrium condition in terms of ion, the potassium pumps, they open, and due to opening of potassium pump, material from ICF, they goes out. And in this manner, materials are transported across plasma membrane through sodium and potassium. So that was the explanation about active transport which occurs through sodium and potassium pump on expense of ATP energy. These pumps here, they utilize ATP energy, and on expenditure of ATP energy and to increase or decrease the charges between ECF and ICF, these pumps, they open, and materials from ECF, they enter ICF, and from ICF they enter ECF. So that's all about the explanation about transport across plasma membrane. I will continue my next topic in my next lecture.